Okay, today we are going to start the new unit that is Stereochemistry. Stereochemistry. And in this one, before going to that one, there are some naming which is related to the previous topics like ionic compound. So we'll go by that one, like a small touch. And after that, we can start this one. Now, if you remember in the previous classes, we talk about ionic bonding and we also talk about covalent bonding. Then we talk about metallic bonding. Sorry. Okay. Now, if you are going to see the names that if there is an ionic compound, for example, you have NaCl. This is an ionic compound. In this ionic compound, if you see Na is a metal and chlorine is a non-metal. So now you know the name. Its name is sodium chloride. Now they're saying that there are some certain rules which you can apply to name the ionic compounds. If there is an ionic compound, the formula is given to you. So how you can write its name? So for that you have some rules. Now we'll see one by one. They're saying that use the following steps when naming ionic compounds such as Fe2O3. Fe, you know that is iron and O is oxygen. Okay, what is the rule number one? They said that the name of the metal goes first and the non-metal goes second. So whenever you want to write the name, for example, they have given here iron 3 oxide. So this one, so which is metal part? This is the metal part and this is the non-metal part. So iron is a metal part and this is non-metal part. So when you want to write the name, so first you will write the metal and then you will write the non-metal. This is the first rule. So it means that if you want to write the name, so first iron will come, then oxygen will come. So this is the first rule. Second rule, change the ending in the non-metal to IDE. For example, they're saying that if you have oxygen, so you will change it to oxide. For example, here you will remove this one and you will change oxide, meaning you will add IDE. The subscript do not change the name. So here, this one you have iron oxide. The first one you will not going to change any name. Second one you will change. For the transition metals, only include the valency of the metal as a Roman number in a bracket. What is that? Maybe you saw, for example, this one we have Fe2O3. So here the valency of iron is 3 plus and valency of oxygen you know 2 minus. So when you make a formula, valency of this comes here and valency of this comes here. So then you get the formula Fe2O3. So here if the iron has valency 3, so you can write in the name like this iron and its valency you will write 3 in Roman 1, 2, 3. It's a Roman counting. Like in Roman counting, you have 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10. It's a Roman counting. So they're saying that when you, if it is a transition metal, you know that in the periodic table, if you see the periodic table, group 1, if this is group 2 and this is group 3, in between all this block is known as transition metals and iron is one of the transition metal. So they're saying that when you want to name the ionic compound and the metal inside that compound is transition metal like iron, so its valency you will write in the form of Roman like 3. and then you will write oxide. There is iron has another valency, that is 2, and oxygen is 2 minus. So when they make a compound, plus 2 minus 2 cancel, the formula is iron oxide. This is also formula, but when you want to write name of this one, iron, so here what is the valency? 2, so you will write 2 and then you will write oxide. So this is how you name if there is a transition metal is there, as they mentioned here. Then they have given another that there silver and zinc, they are transition metals, but they have the fixed valency. This 1, 2, 3, why you're writing 3 here, why writing 2 here? Because iron has more than one valency. Iron sometime is plus 2, sometime is plus 3. In that case, you will write the numbers. Understand? But sometime you have some metal, they are transition metal, but they have only one. So they have the fixed valencies all the time. So you can write there also like this 1, 2, but they are the fixed. So once again, here in this, they are talking about naming the ionic compound. So they're saying that if you have an ionic compound, so there are certain names. And here they are given the formula or the steps. Number 1, name of the metal comes first. For example, if I want to write now sodium chloride, NaCl. So which is metal part? Sodium. This is chloride. So I will write sodium. I will not write sodium valency is plus 1, but I will not write this one because it's not a transition metal. And chlorine, I will change into chloride. So this is the name of this one. Number 2, that ending with IDE, and then transition metal have this one. So they all this is talking about the how the name of a ionic compound, and they have given here the metal. For example, silver, you have Ag plus 1 and zinc is plus 2. So this is the symbol and the charge on them. So is there any problem till here? Please
No.
confirm. Okay. After that, polyatomic ions are charged group of atoms act as a unit. The name of these ions must be memorized. Now, for example, if you see the periodic table, if I talk about group 1, so you will find lithium, sodium, potassium, rubidium, cesium, francium. All of them, they have plus 1 charge, plus 1, plus 2, plus, no, sorry, plus 1, plus 1. If I see group 2, so I will say group 2 what? For example, you have barium, calcium, magnesium, all of them they have plus 2. Then if you have group 3, then you have aluminium 3 plus. If you have group 5, sorry, you have nitrogen. Nitrogen is 3 minus. If you talk about group 6, you have oxygen 2 minus. If you talk about group 7, chlorine minus 1, fluorine minus 1, bromine minus 1. So all this one. So you can see here, all these are elements. So when you want to write, so they are making positive ions. So they are only written atomic, this one element name. So these are known as monoatomic. Monoatomic. Monatomic means only one atom is there. One atom, one atom, one. One atom, one atom, one atom, all one atom. But they use when the word polyatomic, poly means two or more than two. So it means that not only one element, two or more than two elements, they combine together and then they make a ion. Normally, ion is made of only one element. For example, Na plus is sodium ion, potassium ion, barium ion, calcium ion. But when two elements join together, for example, this is what? NO3. NO3, you have two elements. What? Nitrogen, oxygen. Then you have NO2, nitrogen, oxygen. Then you have hydroxide, oxygen, hydrogen. Then you have carbonate, carbon and oxygen. It means that if you talk about all these, they are ions, but they are not made by single element, they are made by two elements. So at that time this ion is known as polyatomic ion, because it is made by two different elements, they join together, now they work like a one. So this is known as polyatomic ions. Now NO3 together it has a charge. What is the charge? 1 minus. NO2 together it has a charge 1 minus or minus 1. OH also have minus 1. Carbonate has 2 minus. So this is known as polyatomic. So you have to memorize them. This is, you have to memorize them, all this one and all these one. This is your syllabus. Now their names also. For example, now try to understand this one. Now this is NO3 is known as nitrate. Then NO2 is known as nitrite. Then hydroxide, OH is known as hydroxide. CO3 is known as carbonate. SO4 is known as sulfate. SO3 is known as sulfite. PO4 is known as phosphate. And NH4 is known as ammonium. So this is, you have to memorize them, how they are used. For example, if in the exam I will write a formula that, okay, write a formula of sodium nitrate. You know that there are two things, sodium and nitrate is what? NO3. So NO3 has what charge? 1 minus. Sodium has what? 1 plus. So they are same, plus 1 minus 1 they cancel. So formula will be NaNO3. This is sodium nitrate. If I say, okay, write the formula of sodium nitrite. What is sodium? Na plus 1. Nitrite is Na2 1 minus. So again they are same, plus minus they cancel. So formula will be NaNO2. If I say write the formula of sodium hydroxide. So sodium is Na plus, hydroxide is what? OH minus. So plus minus again cancel because 1 1. So formula will be NaOH. If I want to say write the formula sodium sulfate. So what is sodium? Na plus. What is sulfate? SO4 2 minus. Now this is plus 1, this is minus 2. You cannot cancel because they are not same. So what will this 1 will come under here, 2 will come here. So formula will become Na2SO4. So this is the sodium sulfate. If I say, okay, sodium carbonate. So what is sodium? Once again, Na positive 1. Carbonate is here. What? CO3 2 minus. So this is plus 1 minus 2. You cannot cancel them. So this 2 will come here. 1 will come here. So Na2CO3. So this is the formula. So like this, these polyatomics you have to memorize. And if they ask the formula, so you can write them. This is the one thing. For example, now instead of this one, I will say, okay, write the formula of what? Magnesium nitrate. What is the what is the symbol for magnesium? Mg. And what is the power of magnesium? 2 plus. And here, what is nitrate? NO3, 1 minus. So this is plus 2, is minus 1. You cannot cut them. So this 1 will come here. This 2 will come here. So it will become Mg. If you write 1, so no need to write 1 because this is simple means 1. Now you wrote NO3. Now this 2 which will come here. So where should I write? Under N or under O? Because this N is for this 2 is for both. So what I will do, I will draw a bracket and I will write this 2 outside. So this is magnesium nitrate. Once again, if a formula comes, for example, I say magnesium hydroxide. What is the magnesium is 2 plus. Hydroxide here is OH minus 1. So this is plus 2 minus 1. They are not same. You cannot cut them. So what will happen? This 2 will go here. 1 will come here. So Mg, 1 no need to write. Now this 2 is for both O and H. So what you will do? You will draw a bracket and under bracket you will write 2. So this is magnesium hydroxide. But when you write here, for example, magnesium sulfate. So magnesium is 2 plus, sulfate is 2 minus. So 2 plus 2 minus same, cancel them. So formula will be MgSO4. Are you getting these formulas? Please confirm.
Yes.
Okay. So like this, they have given, for example, here there is a compound magnesium oxide, MgO. So what is a cation here? Magnesium. And what is anion? Oxygen, and name is magnesium oxide. So naming, for example, if you want to write the name of this one, so this is calcium, this is a metal, this is a non-metal. So metal part comes first and then chlorine part, but you will add IDE, so it will become chloride. And if you have copper, iodine, so copper is a transition metal, so you write is valent C2 here and iodine is here. Calcium sulfate. So here calcium for sulfate, because calcium, as I told you, calcium Ca is 2 plus. Sulfate is SO4 2 minus. Plus 2 minus 2 cancel. So formula will be CaSO4. So this is how the naming of the compound. Okay. Now they're saying that naming the covalent molecules, how you are going to name the covalent. Before that, we are doing the ionic and then we say covalent. For example, here, hydrogen always comes first. If there is no hydrogen, then the element with the lower group number comes first. For example, if there is a hydrogen, then hydrogen will come first. And if there is no hydrogen, so lower group number comes first. Change the ending in the second non-metal with "ide", also I. The prefixes are used. Mono mean 1, di mean 2, tri mean 3 are used to indicate the number of atoms in the formula. So they use like monoxide, dioxide, trioxide. So these are telling the number of the atoms in the formula. The following non-metals elements can exist in diatomic form. So there are some non-metals which always exist in two atoms. For example, sodium is a metal. It can alone sodium like this one atom. But hydrogen, like nitrogen, then you have oxygen, then you have chlorine, you have fluorine, you have bromine, you have all, they are always, whenever you will found them in two atoms together. For example, hydrogen always in this form, nitrogen always in this form. They cannot exist alone like metal. So these type of atoms, or you can say molecules, they are known as diatomic because always they found into form of two. So this is how they you name it. We will see the example, then it will be more clear to you. For example, they said that number one, carbon and oxygen. Got it? If you see the carbon, okay, carbon is in group number 4, oxygen in group number 6. So they said that lower group comes first. So which is lower group? Carbon. So you will write carbon and then you will write oxygen. And how many oxygen there? Two. So you will write di. So carbon dioxide. Then again you see the sulfur and oxygen. Sulfur is group 5. Oxygen is group 6 again. So which comes first? Group 5 comes first. So when group 5 come first here, so sulfur came here. Now oxygen will come here, oxide, but how many oxygen are? 3. So trioxide. Next example, carbon, which group? Group 4. Oxygen, group 6. So carbon comes first, but how many oxygen? 1. So monoxide. So like this, you will name them, and the meaning of dioxide and trioxide. What is that? Any confusion in this? Please let me know. Is it clear?
Yes. So here once again they're telling you the formula when you have to write the formula of a simple ionic compounds. For example, they said calcium oxide. I told you before that calcium is adverse 2 plus, oxygen is 2 minus. So normally if their valencies are same, but only difference is their symbol, it is plus ones minus one, so you can cancel them. So the formula will become CaO, calcium oxide. You can see here, you can write. So here, this is 2, this is 2, you can cancel. So this is the CO2. For example, if you have another one, for example, you have calcium and other you have chloride. Calcium now 2 plus, chlorine is 1 minus. So they are not same now. So what we'll do, the valency of this 2 will come under this one and 1 will come here. So it will become Ca, no need to write 1, Cl2, calcium chloride. So use the following steps to write the formulae. Formulae is a plural of formula. Formulae is a plural of formula of ionic compounds such as calcium oxide. Write down the symbol of the elements with the metal symbol first. They're saying that if they have given like a name like this, so how you will write? So first thing you will write the symbol. For example, metal, calcium, then you write oxygen. Write down the valencies of each element number without sign. So write their valencies. For example, this is 2, this is 2 also. No need to write plus minus. Swap and drop the valencies between two elements. Swap means this will go, valency of this one come here, valency of this one come here, like we are doing here, this one. Then simplify the number. So what is this 2 and 2? Can you simplify? Yes. 2, 1 and also 1. So it will become Ca1O1. So you can write CaO. So this is how you will do this one. Now here they have given the another example, but this is for barium. So here barium is 2 plus it has.
then chlorine is -1 or 1. So you can simplify. Now swap them. 2 will go under chlorine and this will go here. So this is, they have written here. Is it clear? Please confirm. Now the formula I told you, it is a plural of formula. This one. Now, if you have polyatomic ion, we just discussed now. In that case, for example, they have given aluminium is 3 plus and sulfate is 2 minus. In that case, this 3 and 2, they are not similar. You cannot cut them. So this 3 will go here under this one and 2 will come here. So it will become Al2. But this 3 is for both S and O. So you will write for both with a bracket SO4, then this is the 3 here. The step listed in the previous section do apply as well here. Use your own subscript, this one. For example, here, do not change the subscript of these formulae. For example, here, aluminum. For example, now another one, I will write here sodium sulfate. Sodium is +1, sulfate is 2 minus. So now valency will come here, its valency will go here. So it will become Na2SO4. This is 1, no, not right. So this is the formula, sodium sulfate. Now they have given example here. For example, now they have given here hydrogen and phosphate. Okay, hydrogen is +1, phosphate is 3 minus. So this 3 will come here, this will come here, it will become this one. Iron sulfate. Okay, sorry, iron sulfate, yes. So iron is what? 2 plus. Sulfate is, sorry, iron is 3. This is 3. Fe 3 plus, and this one is SO4 is 2 minus. So 3 will come here, 2 will come here, Fe2SO4. And then you have here the number of atoms. Sometime they said that in the exam, they will give you the diagram, okay? And they'll tell you to write the formula. For example, in the exam, they will give you this diagram. And they'll tell you write the formula. So first of all, you write the elements. For example, in this formula, which elements there? Carbon is there. Then you have hydrogen is there. Then you chlorine is there. Then you will count them. How many carbons you have? For example, this is white is carbon, 1 carbon, 2 carbon. So you'll write here 2. Okay. Now how many the hydrogen? So hydrogen is what? This brown one. 1 hydrogen, 2 hydrogen, 3 hydrogen. So 3 come here. Then blue one is what? Chlorine. How many? 1. So this is 1. So this is the formula. No need to write 1. The formula will be C2H3Cl. So sometime they will give you the diagram like this, and they will give you the key. Mean white mean carbon, blue mean chlorine, and this brown mean hydrogen. So write the formula of this one. So this is another way to write a formula with the help of a diagram. Is it clear till here? Please confirm. And then we'll move to the next. Please confirm this one if you got it. Yes, Ahmed.
Yes.
Okay. Now we will do the another term that is known as relative atomic mass, and its symbol is known as AR. Now, the mass of an atom is extremely small and cannot be measured directly. They're saying that if you talk about a mass of an atom, because atom is really, really small, it is the smallest particle of a matter, so you cannot measure this directly. There is nothing that you can put one atom on some machine and it will give you that atom mass. We can, but what we can instead compare the mass of one atom with the mass of standard atom. So we can say that the one we will find, and after that for other we will compare it. For example, we can say, I'm giving the example, let's say hydrogen. Now hydrogen is the lightest atom. Let's say its mass is 1. I'm giving the example, a 1 atomic mass unit. Now, if you have another, let's say you have other one, sodium. Now, what will be the mass of sodium? So, what they will do, simply they will take a scale. On this scale, they will put sodium here, and on other side, they will take one hydrogen, it's not balanced. Then they put another hydrogen, not balanced. Another hydrogen, not balanced. Then they will put 11 hydrogen, then it is balanced. So we can say that the mass of one sodium atom is equal to the mass of 11 hydrogen atoms. In other words, you can say that the sodium atom is 11 times heavier than the hydrogen atom. So if the unit is hydrogen atom, so the mass of sodium will be 11, because 11 times this one. So by this, what we are doing, we are comparing the mass of sodium with hydrogen. So by this method, if you know one of the atom's mass, so you can compare its mass with other. So it's the same thing they are saying, that we can instead compare the mass of one atom with the mass of standard atom. Let's say here hydrogen is standard. Now all other metals or elements you will compare with it. Now they have given their carbon 12 has mass of 12 units. It is used as a standard. Now here in the chemistry, they are taking carbon 12 as a standard. They are comparing the mass of carbon with all other. So what they said that carbon is equal to 12 units. If you want to find magnesium, what is the mass of magnesium? So again, you will put magnesium in one side, and other side you will put carbon. When you put one carbon, magnesium is going down. Then you put another carbon, so now it's become balanced. So it means that mass of one magnesium equal to two carbons. So carbon equal to how many units? 12. So two carbon equal to how many units? 24. So the mass of magnesium is 24. So like this, they are comparing it. So relative atomic mass, they're saying that when they compare the mass of the element with the carbon, so then their mass is known as relative atomic mass. And symbol of relative atomic mass is AR. In the periodic table, if you see the periodic table, for example, you will find carbon, here you will find 6, here you find 12. So this higher number is always AR, relative atomic mass. So this is what is the definition. Now here, the relative atomic mass is average mass of naturally occurring of an element as a scale where carbon atom is exactly 12 units. So they're here comparing this one. In other words, AR of an element is the average mass of isotopes. So sometime the if any compound has isotopes, so you will compare them all together. Then, for example, carbon has three isotopes: carbon 12, carbon 13, carbon 14. So when you add all of them, and then their average will be their relative atomic mass. This is only for those elements which has isotopes. So otherwise, the relative atomic mass of the all the elements is given in the periodic table. So no need to memorize that, it's already given in the periodic table. Is it clear? What is relative atomic mass? Please confirm.
Yes.
Okay. Then you have relative molecular mass. If you see from here, molecular means they are talking about a molecule. It means that more than one atom they join together and they're making a molecule. The relative molecular mass, and the symbol is MR, is the sum of relative atomic masses of all the atoms in one molecule. For example, you have sodium chloride. So now, if you want to find MR of this one, so very simple. So first write sodium here. How many atoms of sodium here? One. Chlorine, how many atoms? One. What is the relative atomic mass of sodium? 23 in the periodic table. Multiply. So answer is 23. Chlorine is what? 35.5. So 35.5. Add both of them. It will be 0.5858. So this is MR of what? NaCl. So how you will find MR? With the help of AR. So this is the method how you can find the MR of any given formula. For example, another, let's say water, H2O. This is a formula of water. How you find the MR of this one? So once again, you will first of all, you will write the number, the elements. Hydrogen is the element here, oxygen is element here. How many atoms of hydrogen? Two. How many atoms of oxygen? One. Multiply by their AR. So AR of hydrogen is 1. AR of oxygen is 16. So 2 multiply by AR of hydrogen 1. So 1 multiply by, why 1 multiply 1? Because 1 atom here, by 16. So here is answer 2, here answer 16. If you add both of them, it's 18. So MR of water is 18. So this is how you will find that one. So here they have given the first of all, they're saying if you want to find MR of any formula, so you have to follow these steps. Number one, identify the elements found in the given molecule. So whatever the molecule is given, for example, here it is given. So first find that which elements are there. For example, if I write a formula MgO, so which elements are there? Magnesium and oxygen. Number two, use the periodic table to determine the atomic mass, mean AR. So see the periodic table. What is AR of magnesium? 24. What is AR of oxygen? 16. Okay. Then you have work out the number of atoms of each element. So how many atoms here? One. How many atoms here? One. Multiply the last two values, atomic mass and number of atoms. For example, here you have magnesium oxide. First of all, which elements are there? Magnesium and oxygen. Then, how many atoms? One. How many atom oxygen? One. What is AR of magnesium? 24. What is AR of oxygen? 16. So multiply them, 24. This is 16. Add both of them, 40. So this is MR of magnesium oxide. So add up the mass of each element to get the molecular mass. So this is really easy. Only you have to just multiply them. You can see here they have solved this one. For example, they have given the formula H2SO4. This is sulfuric acid. So first thing they said elements. What? Hydrogen, sulfur, oxygen. What is AR of this one? 1. What is AR of sulfur? 32. What is AR of oxygen? 16. Number of atoms? Hydrogen is 2. You wrote here. Sulfur is 1. Oxygen is 4. Now multiply them. Here you got it. 2. Here 32, here 64. Now add all of them. So 98 is MR of sulfuric acid. Is it clear? Please confirm.
Yes.
Okay. After that, writing chemical equations. Whenever you are writing a chemical equation, so then what you should know for that one. First of all, what is a chemical equation? Chemical equation is a representation of chemical reaction. If a chemical reaction is happening somewhere, so you can show that chemical reaction with the help of a chemical equation. So whenever you write a chemical equation, so chemical equation has two sides. If you see, this is left hand side and this is right hand side. On left hand side mean the things which are taking part in the reaction, they are known as reactants. Mean the things which are taking part in the reaction or they are going to react with each other, so they are known as reactants. And as a result of these reactants and chemical reaction, what the new thing you are getting, that is known as product. So reactants always on a left hand side of equation and products on a right side of equation, and this arrow is shows that on which side the reaction is going on. So this is known how to write a chemical equation. Now chemical equation can be written into some, you can say, ways. Number one, if you will write the complete name of the reactant and the product. For example, magnesium, Magnesium, oxygen, OXY, complete spellings you are writing. So that type of chemical equation is known as word equation. That's known as word equation. And if instead of writing their name, you will write the symbols. So that is known as symbol equation. That's known as symbol equation. This is word chemical equation and this is symbol chemical equation. So this is the main difference between the word and symbol. If in the exam they will say to you, write a word equation, then you have to write their complete names like here. And if they say write a symbol equation, then you have to write this one. So these are the two types of a chemical equation. After that, they are saying when you write an chemical equation, so it should be balanced. Balancing chemical reactions ensure that the number of atoms on both sides of the equation are equal. For example, how many atoms of magnesium here? 1. How many atoms here? 1. How many atoms of oxygen here? 2. Here, how many? 1. So this equation is not balanced. This equation is not balanced. So you have to balance the equation. So whenever you want to balance the equation, so it is really simple. You have to add thing here. You cannot add anything here, this side. Only you can add before the atom here, here, here. You can add any number here, but you cannot add any number here, this one. Nothing you can add after that. Only in the beginning you can do. For example, if I want to make it balance, so how many magnesium here? 1, here 1. How many oxygen here? 2, here 1. So I cannot 2 put here. It is wrong. Got it? I will put 2 here. When I put 2 here, it means that now how many magnesium here? 2. How many oxygen? 2. Oxygen become equal now. For example, if I want to write here magnesium and here oxygen. How many magnesium? 1. How many oxygen? 2. How many magnesium? 2. How many oxygen? 2. Only now magnesium is, so put 2 here. Now it is balance. So like this, you have to make the equation balance. So balance equation is a correct equation. If in the exam they will ask a reaction, that write a chemical reaction between magnesium and oxygen, and you will not balance it. You will not put 2 here, 2 here. So he has the right to cut your marks. All the marks he can cut from you, or the half marks he can cut from you. You cannot challenge that one. So whenever you want to write a chemical equation, make sure it is balanced or not. What do you mean by balance? That on both sides, the number of atoms of each element should be equal. If there is 2 magnesium here, there should be 2 magnesium here. If on this side, how many oxygen? 2. So here there should be 2 oxygen there. Then it is balanced. When you are writing, for example, when you are writing 2 here, so this 2 will count for both, for this one also, for this one also. So what does it mean? It means how many magnesium here now? 2. How many oxygen atoms? 2. So this 2 is counted for both. But when you are writing down anything here, it is counted only for the same element. So this is how you will balance it. Did you get this one? Please confirm. Yes, Ahmed. Got it or not?
Yes.
O- Okay. Now here, how to balance an equation. So this is, now they have given a formula here. For example, they have given here calcium reacting with HCl. So this is the formula. What is they have written? CaCl2 plus the hydrogen gas. So now this is the equation. Okay. How you know it is a balance or not? So for that, very simple. First of all, you will write the elements. How many elements there? Calcium, hydrogen, chlorine. So three type: calcium, hydrogen, chlorine. Total three different elements are there. Okay, on left side, then make the two lines: left, right, left, right, left, right. Okay. Now on left side, how many calcium atom? One. You write one here. On right side, how many calcium? Also one. You write here. So it means on right left one calcium, on right one calcium. It is balance. For instead of, so okay, in case of calcium they are balanced. Now go for hydrogen. Hydrogen, how many hydrogen here? One. Left side. Right side, how many? Two. Okay, it means they are not balanced. Then chlorine, how many here? One. How many here? Two. Also not balanced. Got it? So now you have two elements which are not balanced: hydrogen and chlorine. So how you will balance them? So if I will put 2 here, now calcium 1, calcium 1, again balance. Now hydrogen, how many here on left side now? 2. On right side, 2. Okay. Now chlorine, how many? 2. On right side, 2. Okay. So now it is balance. This is what. So this is how you will balance the equation. Once again, I'm telling you, you can add the things here, 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 numbers, but you cannot add anything down here. So this is how you will make a equation balance. Now here, as I told you, now it is balance. So this is the balance equation now. Okay. Now, using chemical equations to calculate the mass. Now, let's say you have a chemical equation. Now, here you have carbon reacting with oxygen and giving you what? Carbon dioxide. Got it? Now, use the periodic table. Okay. In the periodic table, if I want to calculate the mass of this side, so I have carbon and I have here oxygen. Carbon, how many atom I have? One. Oxygen, how many atom I have? Two. What is AR of carbon? 12. What is AR of oxygen? 16. So 1 multiplied 12, 12, and here 32. So if I add both of them, it is 44. So this side, the mass of reactant total is 44 grams, let's suppose. Now come to this side. Okay. Here, carbon, how many here? 1. Oxygen, how many here? 2. So again, 12, here 16, 12, 32, 44. So it is balance. So on both sides, it is balance. So what does it mean? If you see in other terms, see that how much grams of carbon here? 12 grams. How many oxygen gram here? You have 32 grams. And how much carbon dioxide you are getting? 44 grams. So you can say that if you burn 12 grams of carbon, it can give you 44 gram of carbon dioxide. Or if you will burn 32 grams of oxygen with carbon, so you will get this one. So this is that according to the law of conservation of masses, the masses on reactant must be equal to the mass of products. You can see here. Here they are giving you 44 total, also 44 total. Now see the equation here that 12 grams of carbon, you can see here, producing how much carbon dioxide? 44 grams. Okay. Then the x gram of, if 1 gram will be there, okay, how much it will produce. So you have to find with the help of this formula. So now here see that use the periodic table to work out the molecular mass. We did that one. Okay. So now here they said that if you compare carbon with carbon dioxide, got it? So here they said that 12 gram of carbon giving you how much of carbon dioxide? 44. And if in the exam they will say, okay, let's say if you have 6 gram of carbon, how much carbon dioxide will give you? So put x, cross multiply them. So it will be x multiplied by 12 and here 6 multiplied by 44. You need x, x will be here. So 6 multiply 44 divided by 12. So 6, 2, and here 22. So if you take 6 gram of carbon, it will give you 22 gram of carbon dioxide. So by this way, this is a comparing method. And this comparing method we use when we solve the moles, the questions. So, but from the equation, you can find that if you have 12 gram, you will get this one. If you have 5 gram, how much you will get this one. So by comparing method, you can find the unknown value of x or anything which you want to find. Please, did you get this one? Confirm.
Yes.
Okay. After that, you have the state symbol. State symbol mean that in which state a atom or the element is there to react. You found this state symbol. For example, S means solid, L mean liquid, G for gas, and A Q mean aqueous means solution form or dissolved in water. So whenever you will find these symbols, so it means that they are going to react. For example, if I say sodium reacting with chlorine and giving you NaCl. So in which form was sodium? Solid form. Chlorine in which form? Gas form. When you get the product in which form? Solid form. So these are the state symbols, that in which state the elements were before reacting or after reacting. So that is known as chemical equation, and these symbols are known as state symbols. Then they use another term that's known as ionic equations. If any equation you will find ions like minus sign, positive signs, this one. So these type of the symbol, the equations are known as ionic equations. These are chemical equations that take place in aqueous conditions and ions are involved. For example, if I'll say to you, okay, write the ionic equation for sodium chloride. So I will write sodium is positive, chlorine is negative. They combine together, they give you NaCl. So this is the ionic equation. Normally, these equations are found in a solutions or in a. So whenever you write the reaction in a, in which ions are involved in this I symbol, you can say equation form. So this type of equation is known as ionic equation. When we will do the salt acid base preparations, so we will see all these in detail. What is ionic equation and how it is formed. So, but they're saying that if you talk about the charges on both sides, it should be equal. For example, here how many, this is minus 1, so how many charge? Negative 2, and here also 2, means minus 1 minus 1, so minus 2. Here also minus 1 minus 1 equal to 2. So the by putting 2 on both sides, the charges of atom become balanced. Again, the balance equations here. So this is how our ionic equation has been written.